Welcome. In this video we'll be talking about how to write out Lewis dot structures, condensed formulas, and line angle structures. To start, Lewis dot structures, think of them very similar to what you've seen in Gen Chem and kind of try to think of them as a puzzle. They're actually really fun to draw if you get in the right mindset. What you get is you get a certain number of each atom and electrons, and you kind of have to figure out where everything fits and where they go together. You want to fill each octet as best you can. And when I say octet, all that means is you're trying to get each atom having 8 electrons. If you were to start with a simple example such as methane, CH4, you'd want to draw the central atom first, which is the carbon. Then you want to add your hydrogens to it. And that's it, you're done. Let's try with a slightly more difficult example. So we have 2 carbons, 5 hydrogens, 1 bromine, and an oxygen. So again, you're going to want to draw your central atoms first. You're going to want to add the 2 carbons. Since bromine only wants to bond once, you can just attach it to one of the ends and just add your electrons in order to fill his octet. And then you want to add your oxygen, which you can add right at the end and attach a hydrogen to it. So that way the oxygen's octet is full. And then from there, if you want to just start adding on your hydrogens. And that's it, you're done. If we want to move on to another little more difficult example, with this one, it's no different than any other one. Just want to add your central carbons first and foremost. And since fluorine only wants to bond once, just like with bromine, you can just attach it, add its electrons in order to fill its octet. You can add your nitrogen right at the end, put its electrons, its lone pairs. And normally, when you see nitrogen and carbon bonded together, they will appear as an amine, but they can still be a nitrile. So from there, you just want to add your hydrogens. And you're done. If we're moving on to condensed formulas, we can start with this example. With the condensed formulas, just think of them as an easy way of writing out and keeping track of everything in your Lewis dot structures. You can write it out just like a book from left to right. So in this example, if we take C8H16O, we can just write it out just like we would for the Lewis structure. So you want to put your central carbons first. And again, this can be written multiple ways. This is just the way that I'm doing it just for clarity for the video. So you add your oxygen on the end. And just start adding in your hydrogens. And then there we have the Lewis structure. So if we want to write out the condensed formula for this C8H16O, you just start by reading it, like I said, left to right. So in parentheses, we can put CH3, 3C. So this, the reason I wrote it this way is because in parentheses, I have CH3 with a subscript 3 after. The reason is because this subscript represents how many of what you have inside of the parentheses. So inside of the parentheses, we have 3 CH3s. We have 1, 2, 3 attached to a central carbon, which is why we put that there. Next, you want to do almost the same thing. You have CH2, and you have 3 of them. You have 1, 2, and 3. And then this part, since it's right at the end, you just add CHO. And this is your condensed formula for C8H16O. That's all there is to it. So if we want an example that's going to let us work backwards from what we just did, starting with the condensed formula, and just write out the Lewis structure from the condensed formula, it's very easy. You're reading it left to right, just like I said before. So we're starting with CH2, so we know you have your carbon with your two hydrogens coming off. You have carbon and a hydrogen, just add your carbon, hydrogen, you have your nitrogen, carbon, and an oxygen. Just like you're reading it, nitrogen, carbon, oxygen. Now I know this doesn't fill the octets, but once you have it written out, it's very easy to see where you can add your extra bonds. So you add one here, you add one here, you add one here, and then the last thing you want to do is add your lone pairs, and that's it, you're done. So just to give you again a really quick understanding, so CH2 is the first part on the left, CH is the middle part, and NCO right at the end. You have 1, 2, and 3. Just like you read it, you have 1, 2, and 3. It's as simple as that. Some good rules of thumb when dealing with the condensed formulas are that the electrons and single bonds are not shown, so don't forget to add them at the end. Bonded atoms are written in their bonding order, so again, just written left to right, just like how you draw it out. Multiple bonds are sometimes shown for clarity, but not always. So again, make sure you're remembering where all those extra bonds go. Groups bonded to the same atom are shown in parentheses, just like how we saw up here. Repeating CH2s are also shown in parentheses, again how we have it just right up here. Handling oxygens can be a challenge sometimes, so really be careful when you're making sure whether it needs to be attached to a hydrogen and a carbon or double bonded with a carbon, something just to make sure you're watching out for where it goes. And for the rings, bonds are usually shown in the formula, so you will usually see an actual ring structure made with the condensed formula. So if we move on to line angle structures, sometimes they're called zigzag structures just because of the way they're written. This is the most common way of showing organic compounds, and oftentimes you will see these compounds written this way in the MCAT or in a lot of your exams in school, so it's a good idea to start getting used to them now, being able to read them really well. Some good things to know before even going into this are that bonds are indicated by lines, and the carbon atoms are located at the intersection of each of those ends and the lines. Hydrogens on carbons are not typically shown, but hydrogens on any other atom will be. Another thing to remember is that double bonds, just like with Lewis structures, get 2 lines and triple bonds get 3 lines. Atoms other than carbon and hydrogen are always shown. One example of line angle structure is butane, represented by C4H10. The Lewis structure I drew out just looks like this. We've gotten some practice seeing what that looks like. So, if we want to do the line angle structure, or the zigzag structure of butane, all you'll have to do is follow the carbons. Remember, carbons are at the ends and the intersection of each of these lines, and the hydrogens are assumed. So, start with your 1 carbon, move to your next, start at that carbon, move to your next, start at that carbon, and finish your last. That's all there is to it. So, if you're a little confused, these 3 hydrogens are assumed on each end because you have 1 carbon, 2 carbon, 3 carbons, and 4 carbons, just like you would here, 1, 2, 3, and 4. So remember, one of the rules states that hydrogens on carbons are not typically shown, but on any other atom it will be. So if you have 3 on each end, and then you have 2 at the intersections because carbon wants to have 4 bonds. So you're assuming 2 here and 2 here. That's all there is to it. If we want to move to a little more difficult of an example, let's try this one, C3H8O. Alright, I'm going to draw this a little fast and then explain why I did that. So with this, all you're going to need is that right there. Now the reason I did it this way is because we have 1, 2, 3 carbons. And just at the ends and the intersections you have 1, 2, and 3 carbons. Again, all of the hydrogens attached to carbons can be assumed but will be shown with any other atom. That's why we added the hydrogen to that oxygen right there, just as it's shown right at the end. That's really all there is to it, but as you can see and you can imagine, it saves a lot of time when you draw out millions of Lewis structures on an exam. Line angle structures saves you tons of time. If you found this video helpful, check out some more of our other videos on our channel. You can get an A in OChem, and we're here to help you as much as we can. Thanks for watching, and we'll see you next time.